Yodle. I'm Matt Lee. I'm a software engineering manager here at Yodle. My email address is there, forward and backwards. So tonight we're talking about microservices in Scala with Akka-HTTP, and I'll be going into some of the other technologies that we have there. Just to kind of get a sense of how deep to go into different things, I want to kind of just raise your hand. Who here is working with Scala in some form or has written Scala? So I figure it'll be most people have at least written some, took the Coursera course, whatever, open a book. What about microservices? Who here is working in some form with microservices? Okay. And who here has used Akka-HTTP? A few people? Who used maybe Spray before that? Okay, same kind of people. Okay. So just if I go too deep or too fast, let me know, and we can kind of tailor it. Most of this I want to be like looking at the code and walking through it and asking questions about that. But to kind of set the stage for us, there's a lot of hype around microservices, right? And so there's been some pushback on that within the industry. A lot of people. People writing blogs and articles and whatever about, you don't really need microservices. You don't want to start out with microservices. Start with a monolith. A well-designed monolith can get you pretty far. And so what I want to kind of, I'm not prove to you, but just say, yeah, we've been there and microservices are really helping us. So, maybe just to kind of examine what your situation is. At Yodle, we're dealing with things on fairly large scale. We have a lot of users, we have a lot of systems, we have a lot of legacy systems that we're trying to update the architecture for. I want to, okay, we kind of take you through the history here of our infrastructure. So our architecture 5 years ago was very monolithic. Monolithic UI, monolithic backend, some unit testing, but a lot of manual testing. We did monthly deployments, and we had some infrastructure monitoring. About 3 years ago, we were doing a service-oriented architecture with coarse-grained services running inside Tomcat. We had both unit and service testing, so a lot more automated testing. We're provisioning hardware, and we're down to weekly deployment. So we're releasing every week this monolithic release, and eventually it starts taking 3 to 4 hours of someone babysitting it to release, and you hope it works. And so within the last year and a half, we've been transitioning to now this microservice architecture. Even before that, from about 2 years ago to the last year, we were taking our service-oriented architecture and breaking off pieces that could be released on demand. So we started to see some of the benefit of being able to push code out to production anytime during the day that's well tested, but bring the system down. Without bringing the system down. Well, sometimes it brought the system down. But about a year ago, we started this move towards microservices, small composable services, all that stuff. HTTP interfaces instead of most of our other stuff is using Thrift. We started using Docker for containerizing. We still have the full testing, but we have on-demand deployment. We have infrastructure monitoring as well as application level monitoring in these microservices stacks. So what are some of the problems that we were addressing? Here's a list, and we'll go through each one of these in a minute. But the solution was, kind of platform as a service, where you, as developers, focus on writing your application, and you don't have to worry about the infrastructure. And we, meaning the infrastructure team who wrote this slide, can focus on making the platform resilient and self-healing and all those nice things that we want, and let us get our code out there. So now, time for a little buzzword bingo. Docker. This is the new infrastructure, our latest and greatest that we've been using for 6 months at least, and really ramping up. Mesosphere and Mesos, Marathon, HA Proxy, Qubit Bamboo, Atlassian Bamboo, New Relic. So that, there's a longer version of this talk that, if we want, we could give it here and go into all the details about all these things. But this is really just kind of a brief overview of what our infrastructure is like and how microservices fit into there. And we might also try to give that at like a Docker meetup or something somewhere in the near future. So the problem of unhealthy services is, you have outages and you have to restart services and that sort of thing. So using Mesos and Marathon, we have this user interface, and we have automated detection of whether a service is healthy. Services report if they're healthy, and if they're not, the infrastructure can restart them automatically if they stay unhealthy for long enough. Bad actors. What's to make sure one service doesn't consume all the resources? Well, you have customizable resources. So you can define your CPU usage maximums and memory usage inside your container. And if something tries to go above that, you can kill it and restart it, or just not let it take up all the resources, and so your services stay up. We had very static deployment topologies. So like our service boxes, we'd have like these 5 service boxes run these set of services, and these 5 run these set of services. And if we needed to scale out just one service, we didn't have a good way of doing that. We'd either have to duplicate one of those boxes and put all the same services on it, or whatever. So we went to a really easy scaling and deployment model. So this is part of the Marathon or Mesos Marathon deployment UI. So we default your services to 3 instances, but if you need to scale it out to 3,000, you can do that dynamically. I don't think we have it where it like auto detects it, but you can configure it and say, okay, I need 5 instances or 10 instances or whatever. So that's really nice. And all these tools are available not just to DevOps, but to the developers, and so that we can take responsibility for it. We had a problem with service discovery. Our first iteration of services, of microservices, REST services, we had the service name, but we also had the environment in there, prod or QA in the name, and it got kind of messy. And how do you find that service, and how do you rotate them around them? Well, so now we have, for service discovery, everything is running through HA Proxy and Qubit Bamboo, I think, and we just have one name that you can use in all the environments for your service. And probably one of the things that affected us most is we as a team would work on something all week and put it in for the weekly deploy, but then the weekly deploy broke because the infrastructure broke, or because some other team had a bug and it had to be rolled back, or certification was delayed, or whatever. And so the work we had done of every team got delayed as part of that monolithic deploy. So the on-demand releases can have the same thing. You could bring down all of the production with that. So we now have a canary pipeline. So the canary in the coal mine alerts the miners if something's bad. When you deploy to production, it actually goes into a canary build. And you can run tests there against production databases, against production systems, whatever. And it can get promoted through this pipeline. And once it passes all those stages and is healthy for some amount of time, it goes into production. So that's kind of our current deployment model, and it's really nice. Bamboo builds it when we're ready. Yeah, it passes all the tests. We click a button, and off it goes into production land. So this is kind of our mantra: is to put everything in Mesos. We call this infrastructure MDMA: Mesos, Docker, and Marathon. So we're aggressively writing new code in these microservices, as well as trying to break things out of the big monolithic and microservices. And so that brings us to the core of our talk. Like I said, I just wanted to get through that to explain why we're doing microservices and and what it means here at Yodle to develop a microservices to go into production. So most of these microservices that we're writing are in Java. We use most of our code is in Java. We have some existing Play apps that are using a little bit of Scala. We have a couple of our services that are using Scala, a little bit of Python here and there. But the bulk of our code base is in Java. And so as these new microservices were being written, our team developed a template so that you can quickly get up to speed and have all the functionality needed for a microservice within the Yodle architecture. So, and that's where the infrastructure work was going. Well, there's a group here that likes Scala and wants to use Scala. So we wanted to develop, our microservices in Scala. But you have to be you have to meet a certain set of requirements to be a microservice in the Yodle infrastructure, right? REST API, great. We use Swagger for our documentation. We need a certain set of health and info endpoints and canary test endpoints. We got to have Docker deployment. We got to have New Relic metrics, and there's a few other things. But that's a good list of things that every service needs to implement. And so that's part of our Spring Boot Java template that we have. And we have, if you've used the the Activator templates, there's a bunch of things, and it goes and grabs a project for you and gives it the name you want and stuff, and brings it down for local development for creating a new thing. We have something like that, or if you've used Giterate. We have a script, and I'll show that in a little bit, to create a new project, and we can just point it at a Git repo, and that's our template project, and then it creates a new project for you. So we kind of need at least the scaffolding for all these things inside our app, a service. So we need libraries to support that. We need a template that makes it easy to bring all that in there. So that's what I'm going to kind of show you a lot of tonight, is what went into our template. So in the beginning, we didn't have a template. We didn't really have a way to write a service in Scala without doing all that stuff yourself. And so 2 or 3 times a year, we have this thing we call FedEx Day, 2-day shipping. It's like an internal hackathon that we do. And so in February of this year, one of the teams decided they wanted to use this new thing called Akka-HTTP and try to write a template for creating Scala microservices. And so they did that, and it was, at some level of completion in just, the day and a half that they had to work on it. And so that sat around in our Git repo for a little bit. So in May of this year, I attended one of the Scala meetups. I think it was it was over at Rackspace with one of the guys from TypeSafe was talking about this. And it kind of dawned on me that Play, we have Play for serving up web UIs, but Play is really just a REST. It could, it's a REST or RESTful interface. It's a web HTTP server. That's all it is, and REST is just HTTP. So why couldn't you write a microservice in Play? And several people here, that are here tonight and we're at the meetup, said, well, maybe you should just use Akka-HTTP. So I went and I played around with it a little bit. And in June, the team I was on and one other team started to need to write a couple of microservices. And so kind of independently, but then working together, we went and resurrected the template and updated it for the current state of things and started writing some new microservices using Akka-HTTP in our infrastructure. And then in July, another team started doing the same thing. Over the course of this, we're not just developing our services, we're putting things back into the template, getting the template in shape. So each time we can add things to it. We're breaking out libraries and all that stuff to make it really easy to bring up a template, to bring up a microservice with very little work in our infrastructure. We have a group here that wants to write stuff in Clojure, and they're kind of going through the same things, taking the stuff we learned about, using some of our things as a springboard to be able to write microservices in Clojure. So why am I giving this talk? Why did I want to write stuff in Scala? That kind of thing. So, I mean, writing in Scala is more fun and productive than Java. I mean, no one's going to argue that, especially not in this group. But I don't see any way you could argue with it. You know, it's kind of fun to experiment with a fully reactive programming model. And that's one of the things that Akka-HTTP doesn't necessarily enforce, but it certainly encourages. And as you get into it, you know, I learned kind of what that meant in this context. I'm going to say the word reactive a lot tonight, so throw something at me if it gets too much. But I hope that by doing this, and maybe by using Scala enough, I'll actually remember what a monad is without having to go look it up on Wikipedia someday, maybe. All right, so we have some internal resources. We have this template. We have these libraries. We have multiple services now as examples. And I think I just heard the closure group is actually going to take one of our services that we wrote and use that as a you know, kind of clone that into closure in a couple different ways to, you know, duplicate what we've done just to, you know, test some things out. We also have started up some special interest groups internally. And so we have a Scala SIG that is kind of responsible for pushing forward the Scala agenda here internally at Yodle. So I don't want anybody to get the picture that we're doing tons and tons of Scala here. We have little pockets of it. We're trying to push forward more, and we're trying to do more with it, and we're learning it. You know, we like it, and we like the environment around it. All right, so enough of the slides. The rest of the time I want to spend going through some of looking at the actual code here. We'll go over some routing, how Akka does routing, because it's kind of different. If you've used Play, Play has a really nice way of defining routes. It has this file, and you map a route and its parameters to a controller, and it all works really nice. Akka-HTTP is totally different than that. If you've used Spray, you kind of get the idea, but if you haven't, then it'll probably be new to you. So we'll go as deep or as not deep as you want. Feel free to ask questions. We'll talk about a little bit about serialization. I want to spend quite a bit of time on the data access, especially using Slick and doing database in kind of a reactive style. Go into a little bit of the Docker here. I'm not going to cover these other things down there. And we're learning painfully that New Relic integration with the reactive programming style don't really, yeah. So, yeah. But oddly enough, you know, TypeSafe just announced their reactive monitoring, Akka monitoring beta program. I think it's part of their commercial product, not necessarily open source. So, yeah. So anyway, hopefully some of that situation will kind of get filled out, but we're a bit disappointed that it's not there. One of our other services is using Mongo and doing some reactive Mongo stuff that I don't know anything about, so I'm not going to talk about it or show it. But that's the end of the slides. I'm going to switch over to with our template. So let me make that bigger. Nope. So we just have this script called create project. Make sure recording. Yeah. And you know, I can give it. I just point it to a repo, give it a service name, and in this case, a branch of that repo, and you know, it'll create a template for me. I'm just going to enter some. I'm doing the cooking show sleight of hand here, where I'm going to like stick it in the oven and then bam, here's the real one. So just because it can take a few minutes to load it up in the IDE, but you can see that, you know, that creates a template that I have. It's, you know, some standard you know, stuff for our template, and that's what we're going to spend the rest of the time looking at. All right, so start here with this is a file called boot, and it extends just the basic Scala app. We stick on a logger, and this is, you know, if you use the Akka activator template, you'll get something like this. And but it has some of our scaffolding in it. One of the things that I kind of like about Akka-HTTP is it is a library that you use in your application. It's not a framework that your application lives in. So that's how it's different than Play in that regard. So this is, we import the Akka-HTTP library, and then this is the, startup of the Akka-HTTP server. And, that creates it. We create some routes. We're using Juice for our dependency injection. So we have this, here's our Juice bindings where we create those. So this is just the application startup. The real fun starts here in this routes file. So, we have this class called routes, and it has an apply method that we use, and it just returns a route. So another nice thing is that routes in this are composable. So you can define them in lots of different places and put them together. So we have a bunch of routes objects here that are injected. So Jetpack is kind of our code name for a lot of that scaffolding that I talked about. Let me actually pop over here to the terminal, and we'll run this. We'll run our app in SBT. So that's going to start up. And so here's our Swagger documentation for this. So anybody familiar with Swagger? It's a fairly nice way to document a REST API. Really, you use some annotations that are kind of messy, but and it doesn't work out of the box with Akka-HTTP, but we've kind of figured out how to make it work without having to handwrite a bunch of JSON. So it just defines the endpoints that you have, and it provides documentation and a quick way to execute them. So like this welcome endpoint, you can see you can define the status codes and tell it what the return types are, and then try it out and get it tells you the endpoint, and here's the response header and body. So this is a post, meaning I can put some JSON in here and type a message, and my route echoes it back to me from here. And then here's an example of I've got a get URL with I can pass it in a client name, and there's no client name Bob, so I don't get anything back. But here at Yodle, we have a lot of customers that are awesome dentists, so there's one of our awesome dentists. So Swagger is just a nice UI to document your REST API and try things out in it. So let's go look at those endpoints that we just executed there. We have here's our welcome endpoint, and here's our client endpoint. So I'm going to go over to a little bit simpler view now to start talking about how the routes are composed. So this is our health and status endpoints. So if I were to
so Matt, one question: do you support any other kind of endpoints other than REST, or is it REST protocol?
For our microservices, it's just REST.
And queues.
And what?
Queues, like we have a Redis queue.
Oh, okay. That's true. Okay. Yeah, we do. So we have queues. So this is a health endpoint, and this is a thing that Marathon checks just to make sure it can talk to your service and your service is responding. There's no database calls here or anything. We also have a more detailed health endpoint that, this is actually going out and checking the disk, checking memory, and then checking the Postgres database to make sure it can connect to it. So that the system can check that, but that's just another one of our endpoints. So this is our library that defines those endpoints. And you can see that, again, this supply method just returns a route. Here we say these are kind of like pattern matchers. If you match health and you're a get request, or the get method, then this is the, okay, go and do this, execute, complete. And the complete directive, it just takes a method. So my controller has a health method that will execute, and we can go look in there and see what it returns. So you can see here I'm actually returning a future of a map of a string to any. So this creates that that JSON format that you saw earlier, and puts the status in there, and that's returned to the completion directive, which all it wants is something that it can marshal. If you look at the complete directive here, it just needs a function that returns to response marshalable. So here's where we get to talk about serialization a little bit. I'm not doing anything explicit here because of magic, right? The magic of Java, or not Java, of Scala implicit. So you see I have this extends JSON serialization here. Akka-HTTP, the examples show you some ways, the built-in spray JSON serializer and deserializer. We did some hunting around and found that they were at least an order of magnitude slower than using Jackson for doing the serialization. But what really sold me on the way we're doing it now is that the default way of doing it, you had to take every one of your, say, case classes and tell the serializer about that class. You didn't have to do the implementation, but you had to say, here's a thing I want you to know how to serialize. And it could do that, but also you had to do that for like all the sub-objects, and you had to worry about how many constructor parameters, because they had functions like JSON format 1, JSON format 2, JSON format 5, JSON, all the way up to like probably 22, which is like the most you can do with a tuple. So you had to declare each one of those in your class. It was kind of painful.
Sorry, which way did you end up going?
So here, I'm going to show you. So here's our JSON serialization class. We're using Jackson and the JSON 4S JSON 4S wrappers around Jackson, but we're just using Jackson. And so this is a trait. So the way we do it now is you have your whatever class you're in, extend this trait, and the magic happens here because all these things get implicitly defined. So there's this two-entity marshaller that Akka-HTTP knows about, and when it finds something that can convert your object to something it knows about in the implicit scope, lots of magic happens, and your object gets magically turned into JSON. So it's using Jackson. What does Jackson use? Probably. So.
So if you change a method name, if you change a parameter name, it will change the serialization.
Yep. Yeah. So I'm not going to go into this too much, but we can talk about it. But it's one of those things that it's really nice. I don't have to worry about serializing the JSON. It just kind of happens. But I need to extend it, or I need to change it, or it's not working, and then I think of the word implicit as a synonym for magic, just because there's a lot of stuff happening that you don't see, and it makes it nice, but it also makes it can be painful.
And so if you wanted to customize it and use another serializer, what would you have to do?
Yeah, go ahead.
So this code is at least a day out of date. One of the patterns we begun adopting is not to use JSON serialized on everything, obviously. And so we create separate wrappers for the types of things we want to serialize. So we may have an object for the routes, contains all the routes that need to be JSON serialized. We have a different kind of object for things that need to be just exposed as plain text, or all the various other things. So we tend to group things, gather things in that sense, as just one way of approaching that problem. But that's what we're doing, breaking that out.
Yeah.
You haven't noticed any performance issues when you're talking to, like, when two microservices are talking to each other as of yet, like in terms of the payloads being sent back and forth?
I mean, there's always a performance hit when you choose to serialize, deserialize, and that has been a topic of discussion and concern at this time. I think at this point we're just often moving forward with it, and since we need to capture the metrics, the system going
Yes.
along, we get a better picture of what we want to do and how things are scaling, and we'll go back and really perform. Nothing we're doing right now is so CPU intensive, right, that we really need to just optimize top to bottom. These things are not done frequently compared to sometimes in that world. So
Yeah.
Scale out 4 or 5 these services.
And more often than not, it's like a database that's the bottleneck, or one of our, legacy systems that's the bottleneck. A little bit of JSON serialization, it hasn't been the bottleneck, at least not yet. And we try to do things in a way where you're not, sending the world, serializing the world to JSON and sending it across the wire. So.
I can't say there's enough recognition of the problems concerned. We are taking into account that there always has to be a path into and out of these things that we can string data through this as quickly as we can. No serializing into the main object, just string the data. We can do that.
And some numbers, I do have a project that actually kind of serializes the world and runs like megabytes a second through it. And I can tell you the serialization is way lower than 1%.
Plus, you're pushing it out over the internet, right? So, I mean, you're pushing it across the network, so that's gonna.
Yeah, that dominates.
Yeah.
And one thing that's really fun to do is punch it with JMeter and just see how far you push it before it breaks. And I think you'll find that it's pretty good stuff.
Yeah. So, we've got this health path here, and here's the composition operator, the path composition, or the route composition. So this returns a route, and then we just depend on to that another thing that returns a route. So we have another path. So if this doesn't match, if we don't have something called health, or it's not a get, and we don't, and that route gets rejected, we just go down the chain until something says, "Oh yes, I match that. I can handle that."
So is this a nested composition? Like, does it help?
The formatting here is a little bit off. I mean, I probably can't format it. It's in the library, but yeah, these aren't this isn't like health/detailed health. It's you can do that. I'll show an example of doing that later. But it's like health, and then
Okay, so
the
these
next
are all root routes.
yeah, these are all at the root, the root of the route.
That style route tends to confuse IDs.
Yeah, and we've kind of taken this formatting style because it compresses them. If you use your IDE formatter, and you have normal how your code is normally formatted with method kind of expanded out onto multiple lines, these route files get really big. So we've kind of taken to putting these directives on flattening out and not formatting them as we normally would. But so that route object that I just showed you that returns a route here, because it's the apply method, I don't have to use it. I can just do parentheses. So this is the same as jetpack routes.apply, that method we were just looking at. And that just returns a route, and so I just compose that route with my debugging routes. These debugging routes, I just added those because I found it useful to have really an error. So let me show you here. you need to test your error handling in your app. So you want to call something to generate an error, and usually what you do is you like go and edit the service to say throw a new runtime exception, so you can see how your code handles the error. So I just added a route called debug /error that we kind of simulate the Java stack trace. We take it and put it in JSON. So this route it throws an exception, and then we have some special exception handling that turns that into a JSON that's useful. Unfortunately, the default exception handler that you get with Akka-HTTP, it was unfortunate for me. All it returns to you is it says, error status 500, internal server error. This is all you would get back from throwing an exception through Akka-HTTP. But we have this, exception handler, and we kind of have written that into our libraries where if we want to use it, we can generate an exception that, actually gives you some context. So if your system throws an error, and this is just a JSON blob, and it comes back as a 500, and you can handle it. I found it useful for simulating an error in like my Play app and figuring out how I'm going to handle the, where I'm going to display the error message or handle the response and that sort of thing.
Assuming the stack trace would be somewhere in some log files.
Oh yeah, it's logged. It's logged on the server. So this is just what you're passing to your client. So I compose it with those routes. So again, these are all just top level routes. We have our Swagger routes that we define to integrate with Swagger. And then I get into the actual business logic route. So here we're defining a path that's API/v1, and we're actually deprecating adding the service name at the end of the route, thankfully. So this would appear, this is the route we were looking at earlier in Swagger as API, v1, service name, Scala Tech Talk, and welcome. So anything that matches this path is going to trigger one of these routes. And you notice that this, our v1 routes here, again, just returns a route. So here we have our welcome path, but we're already down nested inside API v1 service name. Okay, so and then once I'm at that level, again, I just I have some routes, I have client and features, and I just compose those routes together. Here we've got a get for welcome, but we also had that version where we could post a message to welcome and have it come back. So this shows how to do that. So we're actually doing the composition here inside our path directive. So we compose get with now post. And so if it matches post, then we take the body of that as an entity and turn it into a message request. And so here's our message request case class. It's just a case class with a single string. Since we've done that JSON serialization stuff, it knows how to turn JSON that has something called message into a message request, and then pass that to my controller method here. So that's my post, and then I just compose that little route with the rest of it. So that's kind of the basics of routing. If you do the activator template and say give me a new Akka-HTTP app, it's not going to look like this at all. It's going to be I think it's all inside the boot file. It's all inside one file, and it just kind of embeds these routes in with the other code. So we're breaking it out to make it a little bit more structured and composable. Yeah, and there's a ton of them. So you don't know which ones are from some random guy on who's posted something to GitHub versus the type safe one or some company. There's a lot of them out there.
90% of crap that people put out there is crap.
Yeah. So any questions about the route, how routing works? It takes a while to get used to it, but now I'm kind of comfortable with it. You know, we're figuring out how to make this do some things that, you know, like working with New Relic. Richard's trying to figure out how to work with these directives so that we can instrument our calls in the right way. One of the things you'll notice here is this is called Akka-HTTP, but there's no Akka here, right? I mean, if you're used to working with Akka, you're not working with actors, whatever, because really that's all behind the scenes. It's an HTTP library built on top of, you know, Akka streams, really, which is built on top of Akka. So we're not. I'm not. I don't think anybody here is really doing anything with Akka. Or yeah, you did, and I think Charlie did a little bit too. Yeah. Which is kind of nice because you don't have to know Akka and you can do this. But learning this isn't going to, you know, make you understand, you know, Akka. Okay.
Are you going to cover the
Authentication? No, we're not. We've done some of that in our Play app, but no, I wasn't. If you want to talk about it, we can talk about it.
Still leak out when you configure, because it used to be when you to set up Spray, you had to set up like an Akka.
Yeah.
It's very Akka-y in how you
Yeah.
have to configure it.
This is about the extent of it. I mean, in our bindings here.
Right.
Um,
You have to make an active system.
yeah.
Set up a-
We create an actor system, and this gives us an execution context and actor materializer. But not real onerous, but yeah, you do have to do that. And then you got to make sure, because we're using these futures everywhere and stuff, we do have to make sure that, you know, the things that want them have an execution context, and you want it to be the right one. So that can be a little painful. Any other questions?
Well, I have just a question about microservices in general.
Okay.
I don't know if you're going to talk more about that stuff.
Not really, but we can.
So I guess what I wanted to ask about is, you know, one of these key things when you have microservices, you segregate basically your dependencies and all that, but also your data components and data encapsulation. When we've done, you know, we're trying to do component-based stuff on our side. We have some page where, you know, one component is actually writing to the table with another component. Do you guys really have that sealed off? Where your schemas are, you know,
We're working.
really by one microservice?
We're working towards that. In the service I'll show you later, it's kind of the only thing that accesses certain tables, but it does access other tables outside that.
There's been a lot of discussion towards eventually making it so that everybody,
Yeah.
every service is going to run with its own database credentials.
Yeah.
Yeah.
We're moving towards that. I think we're a little bit more towards that way with Mongo if you need to access, if you want to use Mongo. But for Postgres, we're not quite there yet.
Services going across the countries.
Maybe.
Yeah, they're all separate.
Okay, so that's good.
We're in a better position with our microservices. We're more respectful of that vision of what we're doing. It's starting the monolith is a monolith.
It's monolithic in the database, and yeah, okay. This is just to show you. So I started up my run Docker script. I could run through the build, but nobody wants to watch my project build. So this is the info endpoint. So this just kind of collects some build information, and we can define a YAML file that it reads and stuff like that. So this shows up in our UIs that could kind of monitor the system as information. But you notice the URL up there. That's inside the Docker container that it's running in. So I can just, I could shut that down. I mean, I can. You start it up. I'll show you the scripts real quick for Docker, and these are just our development scripts that so you don't have to remember all the Docker commands. So to build it inside Docker, we just write SBT assembly. That makes it all into one big jar, right? And then we do Docker build, and this gives it a tag, and and builds the current service. So that's how you build it. The Docker file, I don't know how familiar you are with Docker. We have our own Java 8 image that we use here at Yodle, and this is the kind of like the commit tag for a particular version of that image. It has some infrastructure in there for the New Relic agent, and then it has this Java shell script that initializes things with the right user and with the right New Relic information, and redirects some logging and stuff like that. So this is pretty small Docker file. Here's where we add our Uber jar into the system that we're going to execute at some point. And then, to run it, like I did just a minute ago, here's some variables that are kind of mimic what Marathon and Mechanic will use to execute the Docker container. And then here's our Docker run with all those variables defined. So, that's pretty straightforward. And like I said, these are just for developers. I don't know if anybody's used them besides me, but I find them really useful, so that's why I wrote them. And plus, I'm not real good with shell scripts, so I would forget something, if I had to do it less than every 2 weeks. Normally, we don't have to run inside Docker. It's just kind of if you're troubleshooting or want to make sure it runs. When I'm running locally and doing dev, I just do SBT run or restart or whatever, and that works fine. So I think the final thing that I wanted to go into here is the database access. So we're using Slick 3.0, which has a reactive programming model. You can read about it. Really, it's like I said, I'm going to say the word reactive a lot, but in this context at least, reactive just means you're doing things asynchronously. You're not saying, I need to do them right now. You're wrapping everything in actions and futures, and this SQL statement won't execute until Akka-HTTP says, okay, I'm ready to execute you now. So as those requests come in, as those web requests come in, I don't know the internals, but think of it as just going on a queue. It's like, okay, I'm going to do that. I'm going to do that later. I'm going to do that later. And then at some point it says, okay, now I'm going to execute this chunk of work. And so what that gives you, in theory, is you're never going to worry about too many requests. Now, obviously, at some point, things are going to fall over, but you're going to be still showing up as available for your clients, and then you're going to give them back something in the future.
So do you have a separate execution context for blocking database calls then, or?
I think it's hidden inside.
Yeah. So,
What was the question?
so the question was,
Inside that DPIO.
is there a separate execution context for the database calls? And that may actually be something that we should look into, because we're like, here's an execution context here that's passed into this call. I'm pretty sure we're just using the same actor execution context.
I think is the issue there CPU versus IO now?
It's the number of threads.
Yeah.
Yeah, so the normal one will give you like 8 on your laptop if you have 8 CPUs.
So depending on how many connections you can have to your database,
Yeah.
you want that number as your execution context.
Yeah. And I haven't done a lot of tuning of this to.
That's where the benefit is for using implicit style for sure.
Yeah, that's definitely something to think about. So Slick, here's kind of I'll call it a directive. It's a SQL interpolated string. We started out using Scala-like JDBC, which kind of has the same structure here of the SQL string. So this actually, you can see some of the syntax highlighting. Oops. And it's highlighting because it knows this is SQL because of the the IDE knows what it is. And so I'm defining this, and this actually returns a Slick SQL action or a SQL action builder or whatever. And then I can say as, and then I have a sample client here. And again, this is just a simple case class that has an ID and a string. And so when Slick executes this, it's going to typecast to this object, and and of course I'd have to define implicit to tell it how to do that. I take the the first long and then the next string, and that's kind of at least one way it's done with Slick. We're just using Slick as kind of a SQL engine, I guess you could say. There's a lot more you can do with Slick in a DSL style. Building your SQL as DSL and modeling your tables and doing all kinds of that kind of stuff. We're just writing raw SQL and using Slick to execute it at some point later. So I haven't really used Slick in that way. I've read about it, but the setup, I'm always a bit leery of that kind of thing. It tries to be an ORM or a DSL, and no, just execute my SQL. Thank you. I can understand what's going on, maybe. Okay, so this function returns a DBIO, which is a Slick thing, and it's going to return a sequence of sample clients because I just have a list. I have multiple rows here. So then the function that calls that, using this database, it calls db.run, passes in this DBIO thing that I gave it, and that actually returns a future. In this case, a future of sequence of sample clients. Okay, so calling run replaces this DBIO with the future, as far as your type is concerned. And then I map that future because I want to turn what's inside the future from a sequence into just one thing, and actually I want to turn it into an option of that thing. So this turns a sequence of sample clients into an option of a sample client. So if I got back 0 rows, I'll get none. If I got back 1 row, I'll get back a sum of that row. If I have 10 rows, I'll get back the first row, wrapped inside a sum. So if I just said .head here and left off the option, that would give me back a future of sample client. But if my query returned 0, I would get a no such element exception because there's no head. So anyway, so that's a real basic, simple query. There's quite a bit of stuff on Slick out there, and I've looked through a lot of it several times, and again, it takes a while to sink in. But once I kind of got the hang of it, it was really cool to think about, okay, I'm telling it what to do, and at some point in the future, whenever things are ready, it's going to execute that, but I'm not saying go execute this SQL now. So it's reactive all the way from the web request down to the database driver. There's some notion of some JDBC drivers that are asynchronous, and Slick might work with those, but
If they're asynchronous, they're not JDBC drivers.
but they're
Database drivers.
yeah. I think some of the databases support some of that kind of thing, and there was some notion of Slick working with that, but generally your JDBC drivers are not, they're synchronous. So yeah.
So apparently Slick 3 has built-in back pressure. I'm not sure because I just read about this recently. Does anybody know how that works with Akka-HTTP?
It's part of the Akka reactive strings spec, so pretty much every
Get it? So pretty much if you use it, you get it?
you pretty much get it, and
Yeah.
it's going to be in Java 9, and pretty much
Yeah.
every kind of reactive framework that you can imagine in the future is just going to have that back pressure.
Regardless of whether it makes sense.
But you're using threads more efficiently if you don't have to. So usually.
Yeah. So that's kind of the simple case of using Slick, and again, this call returns a future which bubbles up to the controller here, and I don't have the types here. I can put the type here. So the controller is returning the future of the option of a sample client. and then this is the function that's called from inside the complete directive, right? And here you can see the messy Swagger documentation. So there's more Swagger annotations than there is actual code in this case. But you know,
Seems like you could write a backer for that, right?
or maybe it could interpret your Java doc to do something like that. That'd be cool. I don't know. Yeah.
There's a lot of options. There's more options than there are hours in a day.
Yeah, I don't.
Yeah, I don't think this problem is not solved well by the There's another project on HTTP for us, which for a while had a project called Run. But they wanted to say that you have an API constructed, so API for documents. But
Well, that's what Swagger basically
give us annotation based.
It can be, or it can be
Or
a
it could
JSON.
So the closure is actually, because closure is data, we're looking at going the other way and using Swagger.
That gets to probably go with
Yeah, exactly.
All right, so this is some more complex SQL, and this is from our actual, partner app. There's nothing really interesting here. It's just, names and addresses and that sort of thing. So, but this kind of does a lot more with, okay, what happens when I have this SQL and then I need to take the result of that SQL and use it in some other SQL statement to populate a table, populate multiple tables, or get the ID back from this and use that in another way, and do that in the reactive slick way, so where everything's returning a future. So we have our domain object. So we're doing an upsert, which if you're not familiar with the weird term, I want to do an update or an insert. So I want to update it if it exists. If not, then insert it into the database. So again, I have my SQL. In this case, I'm using SQL U. So SQL is for selects or inserts or updates, or inserts that return the ID using the returning statement. But if you're doing an update type statement, a DDL statement, you use SQL U. That's just part of Slick. So again, I define my SQL statement here. And it returns me a DBIO of int by default, an update statement, which is the number of rows affected. And it returns notice I'm not doing the run thing here, but it returns a DBIO of int, and DBIO is kind of like a future. It's iterable, so you can do flat maps and maps on it, just like you would a future in this case. So I get back the rows affected. So here I'm using the for comprehension syntax. In other places I use flat map and map. Generally I prefer for when I can figure it out. But my head was spinning in circles doing some of this for a while. So that returns the rows affected. So now I take the rows affected and I'm doing a case match on it. So if I got 0, that means I didn't actually update anything because it didn't exist. So I need to do an insert. So I do my insert statement. If I got back 1, then I'm saying, okay, I was successful, but I want to make the calls all line up. So I do dbio.successful and say I return 1 row. But if I got back multiple things, and that means my update somehow updated multiple database entries, which I don't want, which means something went wrong, so I return dbio.failed.
Does that roll back the transaction, or do you just leave the database in an inconsistent state?
It would, the way Slick works, all of these, I think, all these things that are DBIOs that I'm chaining together will execute together in a transaction. And I do some stuff to kind of sequence them that way. There's different ways to do that.
You need to explicitly set transactionally when you run it. There's some transactionally
Okay.
function, and this will guarantee that it's wrapped in a separate transaction. Otherwise, it's not guaranteed that multiple DBIO actions will be executed in the same DBIO.
Okay.
So we just found a template.
Maybe.
So there's
Maybe.
an option to do it.
Okay. And then, so the result of that, which again will be like a number of rows thing, and and which should be 1, and then I yield that result, which gets returned as a DBIO event. So it'll be a DBIO of 1, hopefully.
With Postgres, you can actually combine both the update and the insert into one statement with a
Yeah.
and you can have a name statement
Okay.
there, and then you can just combine both those into one. That way
Yeah. There's, I'm sure there's lots of neat SQL things that I don't know how to do. 9.4? Okay.
Yeah.
Yeah.
Oh, okay. So it's 9.4? Okay.
When I was looking at documentation a few months ago.
We may have actually looked at that,
This is also, there is a slight race condition in this code.
probably. Yeah, fortunately, this is like not a heavily trafficked function. So this is kind of composition of SQL statements, and then I'm composing them further up here. So this update partner call, again, I'm using a for comprehension to, I just called update the partner and got back the DBIO action. And then, actually, do I return the ID? No, I don't. Okay. I'm calling out to another DAO to update some financial account information for that. And that's, again, giving me back like a DBIO event. And then I'm upserting this partner SQL account, which is another, that's the one we just looked at. So each one of those just executes together, and I return this. And then now I'm actually going to run this set of SQL statements. Well, not really. I'm going to turn that DBIO thing into a future of string. So here, partner type is a string, which is kind of our key for the partner. And so this run method will execute this in a future at some point in the future. So, I'm just composing these things. DBIOs, you can kind of execute them like futures. And so here's the call that calls that. And so there's more things that I need to do than just that set of things in the DAO. So again, I called that add partner, and that returned me a future. And so I get that back. And then I go to some of my other DAOs, and I tell them to do some things, and they return futures. And then I'm returning a result, which in this case is like 2 different things that are used as keys based on the information. So each one of these calls here returns a future, and so I'm just executing those. You can see down here the different style. So if you're not familiar with how for comprehensions are just syntactic sugar around flat maps and maps in Scala, then there you go. These are basically doing the same thing, and I'm not sure. Sometimes there are reasons why the types didn't match up, and I banged my head against it so long that I did it one way versus the other. But I tried to use the for comprehensions because as I'm reading down, it's like, okay, I do this step and this step and this step, and it just kind of flows better with the indentation versus, this is fine too. But, it's just a little bit different to read. So that's, a little bit about Slick used in Akka-HTTP in a reactive way. Unfortunately, we're finding that in order to get to new relic, we're maybe having to throw away some of the reactive stuff, or maybe not. We're still banging our heads against that a little bit. Any other questions on this? This is kind of a lot. We're kind of so this is the end of what I had thought to talk about, and we're we didn't go as long as Sukant went last month, but I don't want to. So. That's true. You had 2 talks in one.
I could have talked that long, all
All right. Yeah. Was it Steve?
Yeah, I was going to ask you about Docker.
Okay.
I haven't really used Docker in order to try stuff. Does Docker actually integrate with Mesos? Is it like part of the container? I don't know a lot about Mesos either.
Yeah.
I guess the better question is, why do you guys use Docker?
So when you want to deploy a thing in the Java world, you're deploying a jar or a war, right? And you've got to execute that. So you got to make sure you have the right JVM installed on the machine. You're probably running, maybe you're running on bare metal, maybe you're running inside VMware or whatever. But you've got to worry about what software is installed on the machine, and you as a developer, you don't have control over those things, right? So what Docker does is it kind of lets you set up your container and do a virtual machine all on your own, kind of, where you can have your Java runtime that you want that's isolated from the outside world. So it's really just a little box that your app can run in. You could run multiple apps in it, but kind of the standard best practice is just one app per Docker container. We expose a single port in and out of that container that can be mapped. So it could be port 35261 to the outside world, but inside it's responding on 8080 or 9000 or whatever. And that's mapped. And so what Mesos is kind of like our VM farm scaler thing. So we have a Mesos master and slave, and I'm going almost as deep as I know about this. Like I said, we have a full talk that I haven't studied up on yet. But, so we have a Mesos slave, and inside that Mesos slave, we're running a bunch of different Docker containers. So our Bamboo builds, the result of that, I can do build docker.sh. It creates a Docker image that has my app, it has a Java virtual machine, everything. And then anything that can do a Docker run can start up my app and map the port to it. And then it can start serving web requests. So our Mesos infrastructure, just kind of sets up a bunch of different VMs that a bunch of different Docker containers can run in. And then we use HA proxy and I guess Qubit on top of that to handle the port mapping and the routing, to kind of round robin or do whatever kind of, so when someone says, I want to I want to talk to foo.services.yodle.com, one time it's going to go, it says, okay, that maps to port 35261 over on this Mesos slave, and then the next one will go to port 38259 on this Mesos slave, that kind of thing. Yeah.
So speak to the employee, you want to say that Mesos itself, kind of,
Yeah.
nodes, and you run a job, you might want to try to attribute that job to that's one of the things that maybe, especially like in the week days, or maybe we're all in the week days, maybe they can long term. But like the idea is you want to map each job, and that there was one project that Matt out of the slides called Marathon, and so Marathon ends up providing this facility to run Docker containers as well. Does that make sense? And so,
There's been a direct link between Mesos and Docker.
well, I mean, big must, but
Marathon runs on top of Mesos.
yeah, yeah.
In Marathon, you can point to your Docker registry, and you have these config files. Well, actually, you can submit them to Marathon, and that'll kick off the application.
One of the other advantages that Docker's allowed us to do is we can run whatever service in whatever language or framework it is, as long as we put a Docker container out there. So that if they want to throw some random Python service into our main cloud, they can. We don't have to make sure that you guys running on AWS?
Oh, I mean, I don't want to be double.
Sorry.
It's on, most stuff is on we have some AWS. One big advantage that Docker's given us is extreme resource management. So we actually run 10 services per CPU in production. And we noticed that when we started putting things in containers, the amount of RAM we could allocate to a service just kept dropping and dropping and dropping. Because we would identify, okay, this service previously when it was in the Tomcat build was taking way more RAM than it should have. And then it was just an easy fix. It's like, oh, this is going to take like a day or two to tech them. Fix it, 10-fold RAM drops. And it also quarantines bad actors. If one is one service is kind of out of whack for whatever reason, you still have 5 more of the same service that are running healthily, and it just our HA proxy will just start load balancing stuff to the healthy servers.
So aside from New Relic, what sucks? Like, what are your pain points?
New Relic, Swagger. I think we got Swagger figured out now. I mean, it still kind of sucks, but we figured out how to do it. Originally, we thought we were going to handwrite the JSON that it served up, so, but we kind of figured that out. New Relic.
The whole reactor model is new for me.
Evangelism.
What do you
Within the organization, just making sure that, like I said, there's a requirement, and if we want to use it in anything more than fringe cases, we've got to make the case that this is just as viable as our Spring Boot Java thing. So
On a testing front, do you just test the REST service endpoints primarily, or?
We test those. We use Scala test it can test the routes directly. We have functional tests that execute like the controllers and things like that. If we think we can't test it in isolation like that, we can also write. We have separate test projects that we can write that actually hit the service and any other services. This service that I was showing, it really just hits the database. It doesn't talk to other REST services right now, but we have plenty of other services that do that. So those would be candidates for what we call a service test or an integration test, or for our UIs that talk to this. Like the partner team has a Play app that is the primary consumer of this REST service, and we have Selenium tests that we run in our infrastructure that we can certify. In addition to the unit and any functional tests that are embedded in the app, an external set of tests that can run, actually bring up the web app and run and execute the things through Selenium. We also started we've been using Karma tests to test unit test JavaScript stuff. So lots of testing. We do one of the things when I came to Yodle I was really impressed with was the amount of automated testing we have. We hardly do any manual testing, which can cause a problem sometime, but just the number of automated tests that we run every night it was more than what I had ever seen. Because everywhere I'd been, I mean, Pratap, you remember the stuff we did at PFI, and it was just all, we had 2 testers, and they would just point and click at the UI. And anyway. Yeah, and so I showed those, briefly the slides. But once we put it into the Canary, we can, the system can inspect and say, what are your test endpoints? How do I call them? What data should I pass? So the service can tell the Canary what to test, and then it'll call those endpoints and do the appropriate thing. And if it passes, then it can promote it. If it doesn't, then it can roll it back. No, the test provides the data. So the test could provide random data.
With an isolated mode, we just have a document in JSON that the test client does, and then it uses a couple of requests just to make sure that the basic functionality works. And then when it goes into partial, it will actually send you a percentage of the production traffic to the Canary service to monitor for exceptions.
We actually have a project right now in QA where we're using the Swagger to auto-generate those tests to check for API violations in Canary. So we can just automatically say, your API just broke, roll back. Yeah, and the great news about that is we don't have to write anything. We just get it for free if we go that Swagger.
We actually have a really strong QA department here. Talking to somebody earlier, I think it's really world-class QA department. When we were in the monolith alone, we were running at one point well over 60 hours of tests every night. As we break these services up, we're redistributing that test load. We don't have to run every test every time we run or deploy one of these things on demand release. So I think that went through the Canary pipeline. So we're really taking this monolithic test structure of tests and finding ways to distribute that and intelligently, so we get the coverage we want without having to have that 65-hour a night test on everything to make sure we're doing. We do regular, I think, cross-board testing as well. We have a really strong test team here that's done a couple of jobs for us.
Yeah, we're hiring, so.
Any final questions? I'll wrap it up and then we can have that topic discussion. Anything else? Well, thanks everybody for your attention and your questions. And